Thank you for returning, guys. Let's take a look at this final example. It says you are tasked with creating a 95% confidence interval for the 40-yard dash times of a local school during a track meet. Of the 25 sprinters, you find their average times to be 4.93 seconds with a standard deviation of 0.3 seconds. Assume the distribution is normally distributed. All right, so it already gives us all the information we need to create a 95% confidence interval. Let's go ahead and start writing out what we know. All right, so we know the average. It said the average was 4.93 seconds. So let's write out 4.93. We don't have to write seconds, we'll just remember it. All right, S for standard deviation. Standard deviation was 0.3 seconds. So let's write that out, 0.3. All right, N is our sample size. How many were there? There were 25 sprinters. So we have 25. Degrees of freedom, remember, degrees of freedom is just our N minus 1, so that's going to be easy. That's just 24. All right, C for our confidence level. We want to be 95% confident, so let's put 0.95. T of C, well, we can look that up on our T chart. We need 95% meets 24. So here's our T chart. We're going to find 95% at the very top. Looks like it's the 1, 2, 3rd column. We'll just follow that down until we find 24. 24 meets 95 at 2.064. So 2.064. Excellent. Standard error. Standard error is going to be our standard deviation divided by the square root of our n. Let's go ahead and put that in here. Well, standard deviation we said was 0.3. Let's put that 0.3 into a fraction. We're going to divide that 0.3 by the square root of n. Well, square root of n is going to be square root of 25. Well, I believe the square root of 25 is 5, so we can rewrite this as 0.3 divided by 5. And we can actually find that on a calculator. So 0.3 divided by 5 gives us 0.06. So 0.06. All right, we know our E is just going to be us multiplying our TC with our standard error. So let's do 2.064 times 0.06. I don't know what that is off the top of my head, but we sure can find out. We've got our 0.06 multiplied by 2.064, and we get 0.123. Let's call that about 0.12. So about 0.12. Well, now that we have our E, all we have to do is add it and subtract it from our average. So let's write that out as well. Our average is going to be 4.93. We're going to subtract from that 0.12. And 4.93 subtracting 0.12 gives us 4.81. So that's going to be our lower. 4.81 is our lower value. Let's do the opposite now. 4.93 plus 0.12. So 4.93 plus 0.12 gives us 505. So 5.05. All right, let's write this out mathematically. Mathematically, it is going to be our lower value, 4.81, is less than our mu. Where'd you go, mu? There you are. Which is less than our higher value, 5.05. And this says that our average will be in between 4.81 and 5.05. So we can be, let's write this out, quote, we can be 95% confident that the average time for all students in the 40-yard dash will be between 4.81 seconds and 5.05 seconds. And that is our answer. Thanks for watching, guys.